Viewers, welcome to this lecture. In this class, we'll be working on Dockerfile. So remember that previously in the last class, we established the fact that there are two methods to create an image in Docker. The first method, which we dealt with in the previous class, is the interactive method. And if you need lectures on that, you can go through the description of this current video. You will find the description of a link to that particular video. So, but in this class, we're going to deal with the second method, which is the Dockerfile. So, what is Dockerfile? Dockerfile is a text configuration file written using a special syntax. So, it's a step-by-step instruction on all the commands you need to assemble a Docker image. So, you have a file and a set of instructions written step-by-step on how a Docker image should be assembled. And so, this command may include installing software packages, copying files, selecting environment variables, and many more. So when you write your Docker file, you build that file, and the result of it is a Docker image. When you run the Docker image, the result of it is a container. So you have a file, you build a file. Building a file is giving Docker an instruction to actually create an image from the set of instructions written in that file. And so an image is created from the file. And then when you run that image, the result of it, what you have is a container. So the basic structure of a Docker file. Now, a Docker image is not one large monolithic file. It is cleverly constructed from a series of layers. So if you have a set of instructions in the Docker file, each instruction makes up a layer. So that means if you have 5 instructions in your Docker file, you are having 5 layers, right? So an image is composed of a stack of read-only layers. So when you hear the word image, which is built from a Docker file, it's a stack of read-only layers. So these layers are created from the instructions in your Docker file. Each instruction in the Docker file is a layer. So each construction in the Docker file, for example, from, copy, run, these are some common instructions. They create new layer on top of the previous one, right? And when you change the instruction, you update your Docker file or change the instruction, the Docker itself will build that specific layer where that change happened with the layer that follows it. So this makes this makes the building incredibly fast. So the concept of base image. So when base image is a foundational layer of the image specified by the from instruction in the Docker file. We'll look at that. Now, before we look at this part, which is the various basic structure of Dockerfile, the various instructions you can have in the Dockerfile, let me explain something critically. So, the Dockerfile will basically follow this first step most times. You determine your base image, you install application dependency, you copy relevant source code or binaries, right, from your local system, host system or local system, and then you configure the final image. Now, I want to use as a case study. Supposing you want to install an Ubuntu, you want to deploy a static file. By static file, I mean just a basic HTML file, right, using a web server like Nginx. The first thing you will do if you are given an empty computer is to install, let's say, Ubuntu, right, an operating system, for example, Ubuntu. Now, the second thing you will do is to install a web server, in our case, Nginx. The third step you may do is to expose port 80, which is the Nginx port you want users to be able to access your web application from. And then you copy your static file into Nginx. So this may be the first steps you follow as an IT operations. In the IT operations, if you want to deploy a static file. By static document, I mean like your HTML document. Now, you can write this in a Docker file each as an instruction. And then each of them becomes a layer. So you see, that's why I say layer 1, layer 2, layer 3. Now, we have official image in Nginx. In Docker Hub, for example, Nginx have an official image, which is Nginx, right? So why would I install Ubuntu and install Nginx? Why would I write this instruction when I already have a base image that does 1 and 2, right? So that means instead of writing the instruction for 1 and 2, I can copy. I can use a base image, and that base image will take care of 1 and 2. So all I will do is just to use that base image. Then my instruction, I only need to write an instruction to expose the port and then copy the static file. We'll see that in action. So basic structure. So your Docker file can compose of some of these instructions. There are more. So that from image, this from is used to specify the base image that the build will extend. So like I gave an example of those instructions. So you can have an image. That image take care of maybe layer 1 to 4, and then you extend from it to write instructions for other layers. You also have the working directory, which is work directory and the path. Now, this instruction specifies the working directory or the path in the image where files will be copied to. So if you are copying file from your host system in the image to your container, you can specify the working directory. So by the working directory, that's where your files will be copied to from the host system. We have the copy host part and then image part. So this instruction is used tells the builder to copy files from the host system and put it into the container image. So you are specifying what you want to copy from your host system to the container image. Then they run and then command. You can use it to execute command in the shell. It executes the command at build time. So when you want to when you are building the image at build time, you can use this to actually run certain command. We are going to see an example. We're going to write a lot of Dockerfile to actually see how this works. But then you also have the command. This provides default for executing the container. So it provides the default command for executing the container. We also have expose. This determines which port the application uses inside the container. So you can expose a port. Like in the case of Nginx, I can expose port 80. So that's the port that will be exposed. So of course, we said we use this as a typical case study. You want to deploy a static file like your index.html file to a Docker container image. Basically, you follow these 4 steps. You install your Ubuntu, which is your operating system. You install your web server, and then you expose the port, and then copy the static. This is what you would have done traditionally if you're in a data center, right? So we're going to follow this step to actually deploy our static file in a container, and then run that container to see how it's being viewed in our browser. So let's go back to our project and work on this project. Now this is a sample example of a Docker file. You can see the first layer, which is here. We said install from Ubuntu 22.0. So this is the base image. Ubuntu is the base image. So it's assumed that from this instruction, Ubuntu is installed on our container image. And then the second says environment variable Debian front end equals to non-interactive. So we want the shell to be non-interactive because we are running a container, so we do not have the opportunity to actually respond to the shell. So we want the shell to be non-interactive. The third layer is copying. We are running an update on the Ubuntu, installed Ubuntu, we're updating, and then we're also installing Nginx, right? Then we'll copy our image file, that's our static HTML file, from our host machine to our Docker container image, and then we expose Nginx on port 80, and then we start the Nginx in the foreground. Now you see this whole instruction is following what's our traditional method. Now, why will I use Ubuntu as a base image when I can use an Nginx? So if you use Nginx compared to this, you can see for this we are using Nginx as base image. From Nginx, since you have an Nginx as base image, it's assumed that Nginx is installed on the container image. It will also install Ubuntu on the container image. So it has abstract for us this number 1 and number 2. So all we just need to do is just to copy our index.html to our container image, right? To our container image. So rather than writing our instructions in about 6 layers. We can write it into layers. So what base image does is it abstracts the necessary instruction we would have written and then extend from that image. We can now extend from that image to write other instructions. So let's look at this in a practical sense. So I have my Docker desktop running already on my system. So Docker is installed on my system. If I go to any of my command prompt and I say Docker image, for example, Docker image ls, I will see all the images currently on my system. I can do Docker. If I want to know Docker install, Docker dash version. So this is the version of Docker installed on my system. Now, supposing if I go here, we have this official image, Ubuntu official image. You can see it, right? We also have Nginx official image on Docker Hub. You can see these are the different tags, right? Okay, so I have this HTML on my system. Let's write the title. I'm going to say welcome to Nginx. Welcome to deployment. So we'll say hello. Hello. Welcome to deploying index.html with Nginx with Docker. If I save this, now if I open this HTML document on my browser, because this is it, if I reload, this is what we have. Now I want to write a Docker instruction to deploy this so that I can have a container running with this image deployed. So I go back to this place. So we create a file. I'm going to call it Dockerfile. So the default name is Dockerfile, right? And so it's giving an error because there's nothing there's nothing currently on the file. So the first thing I'm going to do is to define my base image. Define my base image. In our case, we're going to be using Nginx. So because we're using Nginx as our base image, the next thing I'm going to do is to now copy. I'm going to copy I'm going to copy index.html on our host machine to Nginx image, right? So let's start. So the first is index.html. So you say from, use the word from is the instruction, and then which image you want to copy, Nginx. Now this is the tag, image tag. So if I go back to our Nginx, you can see that this is Nginx. You can use any of the images, any of the tags, but once you identify as latest, what you are saying, you are using the latest version, right? So now the next thing is that I want to copy our image from index.html into Nginx. It's already giving me an option, the option. So you can say copy index.html, and what I'm copying this index.html to this part on our container image, right? As soon as you do this, you have written these two layers, you have written these two instructions, you have written your Docker file for deploying this index.html, right? So we have this instruction written. Now we need to build an image from this Docker instruction, from this Docker file, which is an instruction. So how do you now build? Now to build your image, use Docker image build, options, and then paths. So the options, you have various options. -T, which is tag, you use to define the tag you want to give to your image, right? Then we have -F, which is used to specify a custom Dockerfile instead of the default, right? So there are more of these tags, but majorly we'll be dealing with these two. And then you have, so it's Docker image build option, and then the path to where your Dockerfile is domiciled. So if I go back to this, now I want to build this image. Let me use, I like using git bash shell. So it's the same thing as using the other shell, right? So git bash shell is going to open. So we have it open here. So currently, if I do docker image ls, you will see that we don't have, these are the only two images we have on our system, right? If I do docker container ls, so you have no container running in our system. Now I want to build this image. So the command is docker image build, and then you specify the paths directory where your Docker file is domiciled. We use dot, meaning that I'm in the same directory where my Docker file is. Now we have other ones like options. We have other options. Remember that we say docker build and then options, then the paths, right? So it's docker build options and then the paths. So we have basically two options we'll be working with, which is the tag option and then the file option. So -T will specify the tag. So what do I want to name my Docker, my image? Let's name it our first image, and then you can give it your own tag, right? I will say latest. So Docker build. So if I build this image, right? So it starts building. So it's going to pull this our base image from Docker Hub, and then use that our base image, copy this our index.html to that base image to form a new image, right? So let's watch it. So it has finished building. If I do docker image ls, you can see that you can see our image. Remember that we'll call it our first image. That's the name of the image, and the tag is latest. So it was created less than a second ago. So we now have an image built from this instruction. How do we now run this image? Of course, we treated that in the last class. So you say docker image run, right? So the name of the image you want to run, which is in our own case our first image, right? So you also have options which you can, for example, our -P, which is port mapping. Our image is running on port 80. You can map it to port, let's say 8085 on our host machine, to port 80 on the image, right? So if you run this, you should have your container being built from your image. Okay, sorry, it is Docker container, not Docker image. Docker container run. So we're running a Docker container. That's just 80 on this. So we're running. So a container is built from that image, right? So and then we are exposing port 8085 on our host machine. We're mapping port 8085 on our host machine to port 80 on the image, right? So if I go back to this and say localhost 8085, you can see that we have that application being served to us via port 8085. If I return back, you can see that we still have this running. So I want this to run on the background. I don't want, so you can stop this. if I stop this, I exist from this, right? And return back here and deploy, you can see our image is stopped. So I want it to run on the background. It's Docker container run, and then the name of the image I want to run, right? So I can call it, and that name of our image, before then let's see the image, Docker image ls. So the image we created is our first image. So I can run Docker container run our first image, right? That's the name of the image, right? So we have options. The options dash IT to run interactive mode. Then I can also name my image, right? I can name my container. I want to name my container first container, right? So if you run this command, so you have Docker container run, this option dash LT interactive mode, and then the name of the container is first container. If you run this, right, it's unable to find first image. We may have spelled it wrongly. Let's see. Docker container run our first image, so it's wrong. So its first spelling is first. Our first image, we run it. So it's going to, from this image, so remember that we created this first image from Nginx base image. So it's going to run this container. So, and it's going to run it on port what? Oh, we didn't define the port. Sorry about that. I'm going to stop this. So we didn't define the port. So we have option interactive. You can, instead of interactive, you can use dash G, that's you want it to run at the background. And then let's define the ports. Let's do the port mapping. Dash P. I want to map 80, let's say 86 to port 80 on the container, right? So if we run this, okay, the container already exists. Let's name it second container. Sorry, the name of this container already exists. Let's name it second container, right? So let's run it. So it has created the container for us. So if you do Docker container ls, you can see this is the first container we created. So this is the first container we created, and this is the second container we created. All of them were created from a base, from our image, which is our first image. And in this second container, we are mapping port 8086 to port 80, right? So if I return back to our file, our browser, and then add 86, you can see that we have succeeded in deploying our HTML static file in our container. Now, supposing I change this to, let's say, so this is a standard way of naming your image. Some people might decide to give their image a variant, a different name. For example, I look at the Dockerfile.dev. I can have a situation where I have a Dockerfile for my development environment, I have a Dockerfile for my test, for my production environment, and a Dockerfile for my development environment. So you have custom name instead of the they accept the standard name, which is Dockerfile. Now, if I go back to build this instruction as usual, the way we did before, right? So it's Docker image build, right? So you use your Docker image build, and I want to build it, and I'm building, let's say, I'm going to call it new image. So I'm building an image. Now remember that we specify, we didn't specify. We are usually using the option -t, which is for the tag, and our Docker file is not. We are not using the standard name, which is the Docker file. Now we'll give this Docker file a custom name. If I run this now, watch what happens. Error. Failed to read or open Docker file. No such file exists, and that's true. Now, if I have a custom file name where my instruction is written, so all I need to do is to use what? -f. So that in -f you are specifying the name of your file, right? So dot what? Dev. So I'm saying, okay, this is the name of my file. So right, so if I do docker image ls, so you can see our new image, and you can run your container from that image. So this brings us to the end of this class. We have seen how to actually write a Docker file for a simple HTML document. We are going to extend this lesson to look at writing Docker files for other applications like Java applications, Node.js application, Python application, and we're going to do more complex stuff with Dockerfile in our subsequent class.